Hello everyone, welcome to this NPTEL course on Foundations of Fluid Mechanics. My name is Anubhab Roy. I'm a faculty member here at IIT Madras. Fluid behavior and their dynamics is omnipresent and it shapes the world that we live in. Beyond being a pillar of natural sciences, fluid mechanics is also an extremely visual subject. If you open a tap, pour a cup of coffee, or watch smoke rising off something hot, you've already seen fluid mechanics at work. It also what keeps an aircraft in the air and what makes blood move through your arteries. Fluids are everywhere, and yet describing how they move is one of the genuinely hard and beautiful problems in physics and engineering. What is this course about? This course is about building that description from ground up. We start with a simple but deep question. What is a fluid? And what does it mean to treat it as a continuum? From there, we work through fluid statics, how pressure variations occur in a flow, the forces that fluids would exert on surfaces, why do things float, and what makes sure that they are in a stable state of flotation. Then we turn into motion. How do we describe fluid motion? What is a flow and how do we visualize flow? What is the difference between tracking a single particle to focusing on a fixed point in space? With this, we'll get introduced to a very elegant idea of the material derivative that's going to stitch these two descriptions together. With all that in place, we have next a target to build the central machinery of the subject, the Reynolds transport theorem and the Navier-Stokes equation, where every term in these equations would be derived, and we would also be asking, what does it mean physically? Next, we move to tools. We'll use Bernoulli's equations. We'll also use a powerful tool known as dimension analysis to actually study problems even before we go ahead and solve them. We'll also be solving few flows exactly with the governing equations that we derive, and with that we will probe practical scenarios like pipe flows and then ask question, why are there losses and how do we quantify these losses in flow through various internal geometries. In the end, we'll close this topic with a slightly advanced but very important concept in fluid mechanics, that of boundary layer theory. Throughout, my approach would be on connecting physical reasoning with the underlying mathematics. Not equations for the sake of them being equations, but equations that you can read, you can trust, and you have a sense of what those terms in the equations physically mean. If you have a basic background in mathematics and mechanics, you're already ready for taking a deep dive into the subject of fluid mechanics. So with that, I welcome you into this introductory course in fluid mechanics.